video we will learn how to solve a utility maximization problem. Okay, let us suppose we are being given the utility function of a consumer is, that is utility that the consumer gets by consuming two goods x and y are related with this expression, that is x times y plus x plus 2y plus 2. This is the utility function. And let us suppose that the price of good x is 4 and price of good y is 6 and total income of the consumer is 130. Okay, so this denotes the income of the consumer, this 6 denotes the price of good y, and this denotes the price of good x. Okay, given the prices of the goods and the income of the consumer, we want to find out what will be the optimal bundle choice for the consumer. Okay, so let me draw the graph here, very simple graph. Let us say we have the good x on the horizontal axis, good y on the vertical axis. Since this is the budget constraint of the consumer that he is facing, that means price of x times units of good x consumed by the consumer plus price of good y times units of the good y consumed by the consumer should be equal to the income of the consumer. Okay, now what we do here, we apply the first order condition for utility maximization requires that and let us draw the budget constraint here. If I draw it like this is the budget constraint of the consumer, and this is the the utility function of the consumer. If we draw the indifference curve of this consumer, so let me draw a very simple indifference curve here, that is IC. Okay, what happens at this point where the there can be many indifference curves for the consumer, but we want to find out that very indifference curve which is tangent to the budget constraint here. Okay, budget line rather. So first order condition for utility maximization requires that we equate the marginal rate of substitution between good x and y with the ratio of the prices of good x and good y. Okay, MRS denotes the slope of IC, and this price ratio denotes the slope of the indifference curve. Okay, with the given budget, consumer wants to reach to the highest possible indifference curve, and highest possible indifference curve that the consumer can achieve is that very indifference curve where the slope of that very indifference curve and the slope of the budget lines are equal. Now MRS simply means the ratio of the marginal utility of good x and marginal utility of good y. It should be equal to the price ratio, that is price of good x upon price of good y. This marginal utility of good x means the change in the utility of the consumer due to the change in the consumption of good x. Similarly, MUY means the change in the total utility of the consumer with respect to the change in the consumption of good y, and it should be equal to the ratio of the prices, that is price of x upon price of y. Now this del u upon del x means the partial derivative of the given utility function with respect to good x. Okay, so in the first term we have x, its derivative is 1, we are left with y, plus the derivative of x in the second term is 1, the derivative of 2y and 2 will be 0 because these are being treated, 2y is being treated as constant because we are taking partials with respect to x here, and 2 is obviously constant, its derivative will be equal to 0. Okay, so y upon 1 got we. Similarly, du upon dy means the partial derivative of this utility function with respect to good y. The derivative of y in this case will be 1, so we will be left with x, and derivative of x is 0 because we are treating it as a constant because we are taking the partials with respect to y. Derivative of y in the third term is 1, so we are left with only 2, and it should be equal to the price ratio. Price of good x is 4, price of good y is 6. So let's rewrite it, y plus 1 upon x plus 2, x plus 2 should be equal to, so this is 2 2s are 4, 2 3s are 6, so we get 2 upon 3. So let us solve this equation for y. So y plus 1 will be equal to 2 upon 3. Transposing this term, it will get multiplied x plus 2, which gives us y plus 1 is equal to 2x plus 2 into 2 is 4 upon 3, which gives us y will be equal to 2x plus 4 upon 3. Transposing this one, it gets subtracted. So y will be equal to 2x plus 4, doing cross multiplication, minus 3 upon 3, which gives us 2x plus 1 upon 3. So the value of y is equal to 2x plus 1 upon 3. Now we plug this value of y into the budget constraint. Here the value of y, that means we have 4x plus 6 times the value of y we got here, 2x plus 1 upon 3, should be equal to the income of the consumer, which is 130. Here we get 3 ones are 3 twos are 6, which implies we get 4x. Here 2 twos are 4x again. Then we have 2 ones are 2 plus 2 is equal to 130. So 4 plus 4 is 8x. Transposing this 2, it gets subtracted. 130 minus 2 is 128. Dividing both sides by 8, this 8 gets cancelled. So x will be equal to 8 ones are 8, or now the ba. So we get 48. 8 6 are 48. That means we will consume 16 units of good x. That is, we got the value of x is equal to 16. To find out the units of good y that the consumer should consume at optimal, we plug the value of x is equal to 16, where we put the value of in this equation, okay, in this equation. So which implies y will be equal to 2 times the value of x is 16 plus 1 upon 3. So y will be equal to 32 plus 1 is 33 upon 3. So y will be equal to 11. That means consumer will consume 11 units of good y and 16 units of good x. Okay, I hope I make myself clear in this video. Thank you.